All right, at least I admit it. So, did anybody check to see if the first section of order of operations? When I do order of operations, I always tell a story. And that story is about the guys that go down to the South Carolina football game. Some of y'all may have heard this story. We win a lot of money off of it, as well as a lot of beer. It's about these three guys that go down to Columbia for the Clemson football game. Huh? And they go down to Columbia. They travel down there, 2-hour drive. And they get down there and they get a hotel room. Now, this joke / story was done a long time ago. And it can be done with any numbers, but I'm not going to confuse anybody. I'm going to use the numbers that were used back in 1920 when it was made up. Now, you got dang old South Carolina, dang old state, it's like a triangle, dang old Clemson, dang old Columbia. So they go down to Columbia, and there's three guys. Three guys, they get the car and they go down to Columbia. And they go down there and they say, well, we need a hotel room. So before Columbia got all big and high and mighty, there used to be a lizard thicket right on the outside of Columbia. And right across from the lizard thicket was the Econo Lodge. All right, y'all remember that? Some of y'all remember that? Okay. Well, they stop at the Econo Lodge and it's $30 a night. Per night. And they say, well, we're right outside. We're at this exit. It takes about 15 minutes to go into Columbia, get to the stadium. So that's okay, 15, 20 minutes. If we leave early enough, we'll stay here. It's real cheap. You know, we'll kick the rats out. But $30 a night is pretty cheap. That comes out how much? I mean, there's three guys, right? $10 a piece. And they give the man $30 and they go up to the room. The Econo Lodge back then was just 2 stories, okay? And they stay there, they get in there, and it's about an hour passes. And the guy that owns the Econo Lodge, he's the old man, he's a grandpa. He says, I charged them too much. I gave them a room without blah, blah, blah. I need to give them $5 back. So he takes a $5 bill, and he gives it to his grandson, and he says, go give this $5 bill back to those guys that just came in here. And he goes about halfway upstairs, and he says, how am I going to get the $5 bill to 3 guys? So he runs back downstairs and tells his grandfather, he says, Grandfather, I need 5 ones. And he says, okay, 5 ones. And little grandson goes upstairs and he says, how am I going to get 5 ones, 3 guys? And he said, I'm not going to ask my grandpa again because I'm going to be mad. I don't know what to do, so I'll just take 2, put it in my pocket. And I'll give each one of them $1 back. So they pay how much for the room? Huh? $9 a piece, right? 9 times 3 is, wait a minute, plus $2 in his pocket. Where's the extra dollar? Where's the dollar? He put 2 in his pocket. He gave each one of them $1. $9 to 9 times 3 is 27 plus the 2. What happened? Where's the dollar go? Anybody ever heard this before? It's your parents' fault. First time I heard the story, I was about 17 years old, 16 years old. We were surveying for this guy that had 1 tooth in his head. One tooth. I mean, when he grinned, all you saw was pink. I mean, it was just, anyway. He told me this story. He said, it's a black hole of mathematics. He was smart enough to tell the story, but he didn't know how to explain the answer. There is an answer. He didn't put $3 in his pocket. He didn't drop it. He didn't get a Coca-Cola. He didn't do anything like that. There's all the math right there. Where's the dollar? Waiting. Nobody knows. Nobody knows. Order of operation. Wait, don't we? What did I do first? I subtracted. And then I what? Multiply. You do that. You gotta multiply first, then subtract. So you do 10 times 3, and then you subtract 5. 10 times 3, and subtract 5. What did I do? I did 10. Right. 10 minus 1 multiplied by 3. And then I added 5, or whatever the case may be. Right? The whole thing is, I set up the whole problem subtracting first, then multiplying. And you're not supposed to do that. Well, how do you know what you're supposed to do? Well, most of the time people will start yelling out, please excuse my drinks out. Well, 90% of the time, that's true. Somebody's going, what about the other 10% of the time? I was always told, please excuse my drinks out. Well, when you have a mathematical sentence made up of these two guys, or these two guys, you have to do something different. Now, why did I put addition and subtraction together, and why did I put multiplication and division together? Why did I do that? Why couldn't I put addition and multiplication together? Why did I put these two together, and why did I put these two together? They work together or they undo each other, right? So, you could say that these two fuss and fight all the time, right? And these two fuss and fight all the time because they undo each other. Right? What blood kin fusses and fights all the time? Brother and sister. So if you have a sentence with brother and sister, how do you do it? What's the order of operations with brother and sister? Which way do we read? Left to right. Left to right. If you have a mathematical sentence and you have 3 minus 4 added to 17, then you have to go left to right. If you please excuse my drink salad, you might get a different answer, and it's wrong. Okay? So, as an example, now sometimes it'll come out right, but sometimes it won't. So, you gamble on sometimes it comes out right, or you make sure you know what you're doing. You make sure you know what you're doing. So, 3 minus 4 plus 16. 3 minus 4 is negative 1. Negative 1 plus 16 is 15. Now, if you did negative 4 plus 16, what would you get? You get 12. 3 minus 12 is, you got two different answers. Which one's right? 15 is correct. Because you go left to what? Left to right. I guarantee you somebody in here is going, that's cool. No, it's true. You were just told, please excuse my daring Sally, or you interpreted it as a one shot, one kill. In other words, it takes care of everything. You got it. Or if you're from somewhere else that doesn't use, please excuse my daring. It's PEMDAS. I had a student. I don't understand what you're saying. Please excuse my daring Sally, Mr. McLeod. We use PEMDAS. What do you want to do to those type of people? You not take a bath with a spike on the end of it. We didn't use that. We used PEMDAS. All right. So when do you use please excuse my dear Aunt Sally? Well, let's take this blue marker. Whenever you got a crisscross of these two, these brothers and sisters, akin to these brothers and sisters, what do they call them? Cousins. And cousins go to Aunt Sally's house. So you have a sentence, and you've got 2 times 3 minus 6. You do, please excuse me, let's do 1, 2 times 4 minus 6. Well, I don't want to do it that way. I want to do 4 minus 6. 4 minus 6 is negative 2. Negative 2 times 2 is negative 4. And you're wrong. 2 times 4 is 8 minus 6 is what is PEMDAS? Please excuse my dear Aunt Sally. I really do have students like that. Huh? No. Yeah, just to aggravate me. Okay. I don't know what you're talking about, Mr. McCrow. We use PEMDAS. That was the way these exactly were. And most of these people that I tell you about, they ain't from around here. What does that mean, people from around here? When people ain't from around here, what does that mean? They from which direction? Yep. Nothing against northern people. Most of y'all are nice. It's the damn Yankees. What's the difference between Yankee and a damn Yankee? Damn Yankee needs to go back up north. All right, let's try another. Let's try this one. 3. We'll change it to black. Because it's not, please excuse my Aunt Sally. Black. 3 divided by 2 times 6. Now, no calculators, because we're not using calculators, because I have to use them out. So that means fractions. Well, no, you 2 times 6 is 12, and 3 divided by 12 is 1/4. No, that's not right. Huh? You got to do 3 divided by 2 first, and 3 divided by 2 is 3 what? 3 halves. Multiplied by 6 over 1. Now what? Well, the 2 will cancel here, and cancel with this what? And what's 3 times 3? If you did it by please excuse my dear Aunt Sally, what comes first? So that'd be 2 times 6 is 3 divided by, what is 2 times 6? 12. And that's 3/12. And 3/12 goes down to what? Is 1/4 equal to 9? And somebody's wrong. please excuse my dear Aunt Sally is wrong. Because when you have brother and sister, you go what? Left to right. And that's just a kind of a refresher over the order of operations. Now, a lot of you may say, Hubert, I have never seen that before in my life. And I would say, no, you're probably right. You know why you've never seen this before? Because that's the way I learned it. I came up with the brother and sister and brother and sister and crisscross and cousin. So if you did see this before, it had to be from one of my other students, one of my former students. Okay? Now, did I make up the rule? No. The rule left to right comes from, they just say it, when you're taught the order of operations, they say, okay, if you have a mathematical sentence, you go from left to right. That's why I put in the brother and sister because it kind of helps you remember the addition and subtraction and addition, they undo each other. Now, I'm not going to spend a lot of time on these, but I will show you two words that you need to know for your homework and your test. The two words in your instructions are determine and evaluate. Now, these two words mean the exact same thing as far as what you're going to do in math. How many of you have heard the term plug and chug? All right. If you had an old mathematics teacher or your parents that had an old mathematics teacher, that's where that term comes from. Some people say plug and chug, when it comes to science, when it comes to the formulas, especially in physics. Because your physics, that's all you're doing is plugging and chugging. That's what both of these words mean. When you see these words in directions in your homework or your test, that basically means you're going to plug and chug. But what's the difference between the two? Well, the difference between the two is with determine, you're going to get two solutions. I'll give you an example. Determine if 5 equals 2x plus 1 is a solution with x being equal to 1, or 3, sorry. 2. Right? Determine if 2 makes this, if 2 is a solution of this equation. So what would you do if they give you x is equal to 2? What would you do with that 2?
Plug it in.
Plug and chug. And when you do that, and what I tell students, whenever you plug in something, use parentheses. And you take that 2 and you plug it in right here. And what do you get? That's called an identity. Okay? Write this down because I'm going to go ahead and cover this. Later in this chapter, you're going to get it again. But let's go ahead and cover this. When you there's 3 types of solutions you're going to get in algebra. And I'm going to go over to the next screen. You can go over to the side of your notes or wherever. 3 types of solutions in algebra. One. The first type solution, and usually anywhere from 80 to 90%, this is what you're going to get. And that is a true solution. X is equal to 5. W is equal to 16. Y is equal to 3 halves. In other words, you did the algebra and you came out with y or x or whatever you're solving for is equal to a number. And 90% of the time, that's the type of algebra you're going to be doing. When the directions say solve. If the directions say solve, and you come out with a true statement, like we just did, 8 is equal to 8. 5 is equal to 5. 1/2 is equal to 1/2. In other words, your variables cancel out, and the only thing you're left with is two numbers, one on each side of the equal sign. And if that happens, you've got a true statement, which is called an identity. And when you have an identity, the solution is all real numbers. And we'll get to that when we get later on in the section, in the chapter. We'll get to that. We'll get to this. So on that, determine if blah, blah, blah is the solution of blah, blah, blah. If you do the plugging and chugging, and you get 5 is equal to 5, then the answer is a solution. That is a solution. In other words, 2 is a solution to that equation. And what if you don't get it? Well, if you don't get it, it's called a contradiction. If you don't get it, it's called a contradiction. And a contradiction basically is an untrue statement. I should have put an untrue statement. I'm sorry. Flip it around. Let's just flip it around because that's not bad. Untrue statement. Let's just take this and an untrue statement probably telling us we got classes canceled today because of snowing. Contradiction. No, you just make me mad. 4 is equal to 107. -3 is equal to 4. X is equal to W. -5 is equal to 1/2. These are all untrue statements. And when you get an untrue statement, it's called a contradiction, and the answer is no solution. In other words, you can't get a solution to the problem. So those are your 3 types of answers. Now, most of the time on this test, 90% of your test probably is going to be this. But you may get a couple that comes out to be totally wampus, out of wampus. You know what wampus means, don't you? Out of wampus, out of balance, doesn't jihad. You know where jihad comes from? No, farming term. Anybody know where jihad comes from? You getting there? Not a horse, but not donkey. Mixed between a donkey and a horse. Mule. What does mule do 90% of the time back in farming days? What? Your parents What does a mule do? Plow. Well, how do you tell a mule which way to go when he gets off the center of the road? G means left, R means right. Well, a mule don't know. Mule's smarter than a horse is. And you tell a horse, and you want to get going, and you tell, what do you tell him when you want to stop? Whoa. How does he know that? Is he smart enough to know that? And a mule's smarter than a horse is. They're stubborn. I didn't say they weren't stubborn. I said they're smart.
I was learning to ride a horse, and I was like learning how to make it go faster. And I didn't really like, I was young, so like, that making me go faster and faster, and I knew how to stop it. Then the guy like from behind just screamed at it, and he slammed in my face.
My dad bought me a pony.
Yeah.
I never did care for it. It's beautiful. I love horses. It's beautiful. Anyway, I got on this pony. And I decided I was going to open her up on the pasture beside my full road. Just open her up. And she opened up. I was going. Just going. Until we came to a pylon. And guess what that dang pony did? I don't know how she stopped that quick, but when she stopped, I went. And I never get back on it. I don't care nothing about it. But anyway, jihad doesn't jihad. It's out of balance. In other words, it doesn't work. These don't work. And if you don't believe me on jihad, Google it. G-E-E, HA, H-A-W, jihad. Google it.
How easy.
I'll take up time during class, and somebody will complain to my boss, and then I have to send out the body in here, and then y'all will pay for it. All right. So let's go back. So this is a true statement. So yes, 2 is a solution of this equation because you plugged it in and you got an identity. Evaluate. Evaluate is when you're given this. 2x plus 4 is equal to y, and x is equal to 3. Basically, what do we do with that 3? Plug it in. 3 will go into 2 times 3 plus 4 is equal to y. And what is 6 plus 4? So y is equal to 10. And we just got one of those solutions that you'll get 90% of the time. Now that's pretty much going to be what you're going to be doing in the first section of 5.1. This is what you're going to be doing for homework. Is this a solution of this equation, or evaluate? Here's another evaluation. (2x plus 3y is equal to 16. X is equal to 4. Y is equal to 3. And then they'll ask you, is it a solution? So I'm sorry, determine. Sorry. They don't even have to say determine if so-and-so. You're supposed to know that if they give you an equation and it has x and y in it, and then they give you x is equal to blah blah and y is equal to blah blah, you're supposed to know that you're going to do what? So 2 times 4 is equal to 3 times 3. Oh, sorry. And 2 times 4 is 8 plus 9. Is that a true statement? So what is this? Contradiction. It is not a solution. So this is not a solution of this. And that's pretty much going to be all your 5.1 homework, or whatever chapter you're in. So 6.1 homework. Plugging each other. I'm not going to spend a lot of time on it because you're talking about 10% of your Unit 2 test, which means probably 1 or 2 questions. One of them will be an evaluation, one of them will be a what? Determine. So I'm not going to spend a lot of time on it. I do want to spend a lot of time on algebra. because you're talking about 80% of your Unit 2 test is going to be the next couple of sessions or next couple of times we meet. It's going to be what it's going to be about. So if you want to go ahead and work on the algebra section, that's fine. I don't know what section it is. It's probably 6.2 or 6.3. Somebody tell me what 6.2 talks about. That's where it starts. 6.3, what is this? Formulas, no. Don't worry about formulas. That's only 10% of the test too. What's the next one? 20%, but we're going to do that last. What's the next one? Sorry? What? Variations 10%. It's very small. Next one. There you go. And what's the next one after that? Okay, I break this chapter up into two. I break this unit into two tests. The first one is going to be 80% from 6.2. And what was linear inequalities? 6.2. Okay? 80% of your test is going to come from those two sections. So you better make sure you know how to do those homework problems. And I will give you the worst problems I can make up. Okay? Because one thing I want you to be able to do when you get out of this class, when you see a fraction, you just say to yourself, okay, I need to do this, this, or this. When you leave my classroom, I don't want you being afraid of it. And I showed you how to add fractions. You should be able to add and divide, and you should be able to add and subtract fractions with no problem there. So now we're going to do fractions in algebraic equations, which depends on the common denominator. Again, you're starting to see why people don't understand how to do algebra. Why don't people understand how to do algebra? They don't understand fractions because either they didn't listen or the teacher didn't teach it. Just do them. Now, there's four operations. X plus 4 is equal to 6. X minus 2 is equal to 12. 2x is equal to 14. And x divided by 3 is equal to 12. Now, before everybody gets all happy and say, oh yeah, I know how to do that, this ain't going to be on the test. Okay? This is what everybody knows how to do. But you got to start somewhere, so this is where I start. There's two things that you need to remember about algebra. One, your main goal is to get the variable, what? By itself. By itself. I don't know where that came from. That sounds kind of risque. It's left. What's the second rule? Well, the way that you get the variable by itself is you use the theory of equality, which basically says if you do it to one side, you got to do it to the other. So the theory of equality is number 2. What you do to one side, you have to do on the other. And most of y'all know those two things from pre-algebra. Whether you took it 5,000 years ago, as some of y'all say, or whether you took it last semester in 032 or whatever it's called. So everybody knows that if you want to get rid of a positive 4, you what? And by the theory of equality, minus 2. You do it on the other side, and that goes away, and you get x is equal to 2. And most of y'all can do this in your sleep, and that's not what I'm going to test you on. Well, then where do people have problems with algebra? It's when you throw the other things in with this. So how do you get rid of a negative 2? You add 2. You do it on one side. You add 12 on the other side. And you get x is equal to 14. Becomes that. Yeah, I have negative 2. How do you get rid of 9 by 2. And if you divide on one side, it's equal to 7. And how do you undo dividing by 3? Multiply by 3, and x is equal to question. Then where does the problem come? The problem comes when I take that problem, x plus 4 is equal to 15. I take a problem like that, and I add fractions to it. I add parentheses to it. I add x plus 4 equals 15 times x minus 2. I add another term on the other side. That's when y'all start going haywire. That's when everybody starts throwing their pencil down and quit. Because everybody knows how to do this. This is your Mickey Mouse watch right here. And this is what you get when you add to it. So let's go over the first thing. First thing I'm going to cover is multi-step. In other words, this is one step because you do what? You subtract on both sides. That's it. Then what's multi-step? Multi-step is when you have another step in it. All right, take a minute and work on that. It'll just take a few seconds for some of y'all. Some of y'all can remember it from pre-algebra. Alright? How do you know what to do first? Well, if you're one of these people that made it through pre-algebra and never understood what to do first, just remember, draw a little man right here. What's the goal of the little man? To get the variable what? So reach out to that variable. 10. Why? 4's in the way. So he can't get to that. So what does he do? Gotta get rid of the positive 4. Now a lot of people say, just do PEMDAS backwards. Whatever. Yeah, you can do PEMDAS backwards. What comes first? Let's see, first using again, Sally. Subtraction, then addition. There's no subtraction here, but there's addition, so you undo it first. I think it's a whole lot easier to do little man. I like PEMDAS. Okay, well you just use PEMDAS. Divide by 2. I come looking for you. I wanted you to do me a favor. I need a drink. Not that kind of drink. Huh? Okay, well, just forget it then. I think you'd be going the wrong place. I just thought you were going downstairs and I was going to get you to get in the room. All right. X is equal to 6. So that's your answer. How do you check it? Anytime you want to check it, plug it back in. So take that 6, and I'm not going to do it. I'm going to let y'all do it. Plug it in right there. What's 2 times 6? 12 plus 4 is? So this is a 90%. This is one that you find X is equal to a number. All right? Say again? Oh, what time is it? What time's class over? 2 what? Okay, I got 5 more minutes. Okay, thank you. All right, let's do a narrative. This one is 3 steps. This one is where I get into something that is, I get into teachers teaching stupid stuff. All right, freeze. Attendance. No sneezing, please. Let's see. February 18th. All right, Brown. Carey. Dawson. Dedu. I know that's not right. Edwards. Elliott. Grubbs is here. Lee Croy. Littman. Littman, did you get, where'd you at? Did you get my email back? Okay. I was crying the blues. Pardue is here. Queen is here. Rochester, not here. That's why those pictures come up, I guess. I don't know why they come up. Roebuck. Satterfield. Roebuck's not here. Shaw. Both my Smiths are here. Vernon. Whitfield. Williford's not here. Oh, Lord. He's in the ice somewhere. And Wright. Now, this problem I have fun with because some teachers tell you have to take the 4x over to the left. No, you don't. If I was to take y'all out on the farm and I was to give y'all all a job, and your job is to go out to the barn and get a bucket of feed and feed cows. You got a trough over here, it's real simple. You get a bucket of feed, you put it in the trough. Not the bucket, but you pour it out in the trough, okay? There's 2 buckets in the barn. There's a 5-gallon bucket and a 15-gallon bucket. Now, if I tell each of you, if I say, go out, get a bucket of feed, and give it to the cows, which bucket is 99% of you going to pick? Why? It's smaller, and it's lighter, and it's easier to handle, and we are all what? Lazy. Okay? We're all lazy at heart. I mean, if there's any way to get out of doing something, we're going to what? Do it. Hubert didn't specify which one. What about the other one? Who's going to use a 15-gallon bucket? The same person uses 2 times 27 equals 54. Okay, there's always one. Okay, remember the first day of factoring, I asked you what 54, factor 54? And I said 99% of you is going to say 6 times 9 because it's your multiplication table. And I said there's one person that's going to say, oh, that's 2 times 27. Okay, well that 2 times 27 person is going to be the one that picks the 15-gallon bucket. All right? So, all of us are lazy. All of us are going to pick the what? Smaller bucket. Which one's the smaller bucket? The 2x or the 4x? Well, you're going to move the smaller bucket. Oh, my teacher said y'all was supposed to put the x on the left. Go to some of y'all that do the park thing, take the kids to the park. I don't do that. I never did. There's this thing there called a seesaw. I don't know what a seesaw is, Mr. McClure. We call it a teeter-totter. You go up to Salem, and you got another teeter-totter.
No, we call it seesaw.
This one's in Ivor. I'm sorry, South Ivor. And this one is in Salem. Now in South Ivor, you got two kids. One's named Jody, one's named Susie. In Ivor, Jody sits on the left-hand side, and Susie sits on the right-hand side. You go up to Salem, Jody has to sit on the left-hand side, right? Why not? You recall that 4x has to go on the left-hand side. So when you go to another seesaw, Jody can't sit on the right-hand side. How much sense does that make? Huh? It will give Jody a complex. He'll grow up and live in a ditch because he can't sit on the right-hand side. Why is that stupid? Because you can move on the equal sign, you can move either or. Now, why do I tell you to move the smallest number? Why do I tell you to move the smallest bucket? Why? What is the most important goal? Get the variable what? By itself and positive. Because if you get it by itself and positive, you don't have to remember two other rules later on that you're going to forget on the time test. So, it's either learn one rule or learn three rules. Which one do you want to remember? I want to do one, and that's what I'm going to do. That means if you have problems with yours and you get yours wrong, you see me after class because I'm not going to do it. Because I'm not going to confuse people that are learning how to do it correctly. So, I'm going to take this small bucket and I'm going to move it over here because I'm lazy. Why do we not move the 4? Because we don't care about the 4. All we care about is the what? The variable. The 4 is like a tail on a kite. We're moving the kite. The tail does what? It follows. You don't worry about the numbers. So, -4 is equal to, let's say this is River Jordan. Cross over the river, Nile River, Cross over the Nile River, you're crossing over into another world, aren't you? And that is, the opposite of this is that. Now that's one way you can remember, or another way is take, the theory of equality. If you want to get rid of a positive 2x, what do? You subtract 2x. So we get -4 is equal to 2x plus 7. Now we've got our variable by itself, except we've got a 2 in front of it. Now we've got the little man, the 7's in the way, so get the 7 out of there. And you get -11 is equal to 2x. Now what? And x is equal to -11/2. Now, before I let y'all go, there's 3 people in here. One invented how to do algebra. Okay? They did it and they got 11 is equal to -2x and they just divided by that -2 and they got the right answer. Well, that's fine and dandy. But when we're working with inequalities, if you divide through by negative, you have to remember another rule, which means what? You have to flip the inequality. You're going to be on a time test. What are you going to make? What errors are you going to make on a time test? Simple. Is remembering to flip the inequality and remembering to divide through by negative, is that simple? That's what you're going to forget. So, just the two people, the people that are remembering and the people that don't know how to do it, you might want to move the smallest button. Okay? Y'all get out of here. Somebody hit my button, please. Vanna, would you do that for me?